using this information, we want to solve this one. If n equals to 16, find C so that your alpha is 0.05. Okay, again, remember back. What is your alpha? Your alpha is probability rejecting H0 when your H0 is true. Okay, so that's mean you will have, okay, you will have your alpha is 0.05. So probability of rejecting H0, you already have your critical region, X bar greater or equal to C. So under H0 is 2, you have your mu is equals to 15. So now this is your alpha, which is 0.05. Okay, standardize. So you need change to Z. So C minus, okay, now C, you used the answer before. So C, we already have, sorry, you want to find C, sorry. C minus 50, okay, divide by your sigma square, okay, divide by n. Your sigma square is 36, your n is 16. Okay, sigma square divide by n, so 0.05. From your stats table, it gives you C minus 50. You solve this one. So 36 divided by 16 equals to 1.6449. Okay, from the stats table. So it gives you the value for C. Okay. So in this case, check the answer. So you have C is equal to 52.467. So that means we will reject H0 when our X bar is greater or equals to 52.467. Okay. So our conclusion, we will reject H0 when X bar greater than or equals to 52.467. So otherwise, we will accept our alternative hypothesis. Okay, so we only reject our H0 when X bar greater than or equals to 52.467. So this is the value for C. When we have the value for critical region, we already solved finding the best critical region. How we want to find the best critical region? We use the Neyman-Pearson Theorem. Take the ratio of your theta naught and also your theta 1, your null and your alternative. Set that one less than or equals to K. So since we want to eliminate the exponential term, so we use ln. Okay, take both sides ln. Okay, and then simplify. So again, you have minus summation Si. So again, if you have minus, we will change the inequality so it becomes greater than or equal. Okay, so since you want to solve for normal, so change to X bar. So we will reject H0 when X bar greater or equals to C. So this is the best critical region, X bar greater or equals to C. So given second part, you already have your alpha. You already know what is the definition for alpha. Rejecting H0 when H0 is true. And then you substitute. Okay, so Z greater than C minus 50 divided by your square root sigma square over N. So from your stats table, you will have 1.6449. And then lastly, solve for C. Okay, solve for C. So you will reject H0 when S bar greater than or equals to 52.467. Okay, to complete dia punya first example. Okay, so dia punya, again, dia punya weightage marks pun little bit banyak lah Sebab kalau let's say the critical region is not given, maksudnya kita akan reject H0, keadaannya macam mana kita tak tahu. So that means you have to find the best critical region. So first part, find the best critical region. Once you get the best critical region, okay, given this situation, what is the probability. Or you want to find C, you can find C, or given C, you want to find N. So it's boleh juga, dua-dua boleh ya, mana-mana satu. Given that the value of alpha ataupun sebaliknya ya. So that one the first example. Okay, do you have any question? Ada tak?
Betul.
Ya.
Macam mana nak tahu kena pakai apa? Neyman-Pearson yang mana satu?
Okay.
Yang mana satu? Kali tiga.
Yang mana satu maksudnya less than or equals to K ataupun greater than? Itu kan maksud kamu?
Macam mana kita nak tahu macam mana kita nak tahu kita pakai yang mana satu?
Okay, normally we use yang second one tu, inilah less than or equals to K. Sebab kalau yang greater than or equals to K ni kita kena tukar ni, dia C prime. C prime is your acceptance region. Yang C ni kamu punya rejection region or your critical region. So normally kita, biasanya kalau saya buat, saya ambil yang ni lah, yang ni je. L theta naught, likelihood for theta naught divide by likelihood for theta 1 less than equals to K. Okay. Tapi less than equals to K tu, dia tak semestinya akhir jawapan kamu tu akan jadi summation macam ni lah. Kamu ada minus summation xi less than equals to C. Sebab kita ada minus, so inequality dia akan bertukar. Maksudnya kamu akan reject H0 when you have summation xi greater equals to C. Again, kita tukar pada X bar lah nanti. Okay. Satu lagi, one more thing, if you need to check, nanti later on mungkin kamu akan perasan lah why summation xi tu greater or equals to C. One more thing you have to consider ini. Null kamu mu equals to 50. Your alternative is mu equals to 55. It's the same thing if I write alternative mu greater than 50. Betul tak? Kan? Ini alternative ni saya boleh tulis, I can write mu greater than 50. Tapi kalau saya tulis mu greater than 50, it become composite hypothesis. Lain pula cara, lain sikit cara dia. Okay? But this one simple hypothesis because we want to substitute the value mu equals to 50 for theta naught tadi. Theta 1 alternative dia mu equals to 55. Kita ada value. Okay. So that's why we call this one as simple hypothesis. So that's why kita punya rejection H0, kita akan reject H0 when X bar greater than C because alternative kamu ni kalau kamu put check mu equals to 55 is greater than the value of your null hypothesis. Macam kamu, kalau kamu ingat balik dalam step 1, katakan kamu nak test parameter theta equals to 2, alternative dia theta greater than 2. So katakan kita buat rejection region kita pakailah standard normal. We will reject H0 when Z test greater than Z alpha. When your alternative is greater than. And otherwise, if your alternative is less than, reject H0 when Z test less than minus Z alpha. So dia akan follow macam tu. Okay. So again, if you want to check whether your answer for your critical region is correct or not, you check what is your null, what is your alternative. If your alternative, the value is bigger than your null hypothesis, the last answer here should be greater than. Dia tak akan jadi less than. Okay? Dia akan cancel out lah negatif ke apa ke positif ke macam tu. Okay, dia akan jadi greater than. Kecuali lah, let's say, you have a two-sided test. Two-sided test dia lain pula lah sikit. Okay, two-sided test dia ada cara lain. Sebab yang nak finding the best critical region using Neyman-Pearson ni, for this one, for this example, for this section lah, certain best test ni only for simple hypothesis. Maksud simple hypothesis, when you have the value for null, you have the value for alternative. Alternative tu dia tak akan jadi mu greater than. Okay, ni kita akan pakai Neyman-Pearson Theorem. Tapi for the next one pun, kita akan pakai Neyman-Pearson Theorem juga, tapi different approach sikit, different cara penulisan tu lain sikit. Okay.